In this session, we'll see how to assign wind loads. I'll go to define load patterns. Okay, I have previously worked with this model, so you can see WLX and WLY. So I'll just delete it. If you're not worked, I mean, with the application of wind load before, so then that doesn't appear here. So what I'll do is I will add a new load. Okay, I will add a new load. So I'll give it as WLX. Okay, then let that be wind seismic weight, sorry, self weight multiply, let it be 0. So I'll select Indian code, that is IS 875 2015. So in the ETABS 18 version, you can see the 2015 edition code. Maybe in the previous version of ETABS, you can find 1987 edition code maybe. Okay, so I'll add a new load. Okay, I'll add wind load in Y direction, so WLY wind. So IS 875, add new load. Okay, so WLX, I will modify it. Okay, so exposure from extents of diaphragm, let it be the same. So wind exposure parameters, wind direction of exposure width. So in that modify. Okay, so the ETABS can take both 0° and 90° together, but no, I prefer taking one at a time. So first I'll consider 0°. Okay, so wind coefficient, I'm sorry, windward coefficient and leeward coefficient. So this you get based on the building dimension and also from the table in the IS code, so which you need to calculate. So no, right now I'm not calculating those values. I'll keep as it is. So if you based on the building dimension and refer the table in the IS code to get the coefficients, windward and leeward coefficients. Okay, so wind speed, I'll consider the building in Mangalore. So 39. Okay, terrain category, there are different terrain categories. So if it is in a city, I can select 4. So importance factor. So this is not any building, industrial building or any building vulnerable to mm, vulnerable building. So I'll consider it as 1. So these two I'll take it as it is 1. So top story, so LMR, and bottom story from foundation, there is no wind load will be applied. So I'll take it from plinth. So include parapet. If you want the load to be applied to the parapet also, you can include it. So our parapet height was 1.5. So I'll give it as 1.5. Okay, now I'll modify the wind load in Y direction. So modify. So here I'll give it as 90°. And here I'll give it as 90°. Okay. So this you need to calculate windward coefficient and leeward coefficient. Just to differentiate from the X direction, I'll give it as 0.7. And this is 39, considering the building in Mangalore city. So this I'll consider 4. 1. So this is from the LMR to plinth. And if I include parapet, it is 1.5. Okay. Okay. So to see the load, you go to assign, display load assigns, because the load will be applied in the joint. So you have to see the joint load. So WLX apply. Okay, you can see the wind load that is applied. Okay, if you want to see it from the other direction, that is WLY. Okay, apply. Okay, you see it in the same direction because only after the analysis we get to see in the other direction. Okay, so what I'll do is just to show you, WLX and WLY. What I'll do is I just run the analysis now. even though we are not in a point of running the analysis because we have not done the load combination. Just for this wind load, I'll just run the analysis just to show you the load that has applied in the y direction. So now you can see the load which is applied in the y direction. Okay, so I will unlock it. So if you want to work with the project after analysis, you have to unlock this, you have to press this button. Okay, so this is how you apply the wind load to your model. Okay, yeah, thank you. In the next session we will see the different other lateral loads and the uh, no the analysis results. Thank you.